Your Ford F-150 is actively destroying its own turbochargers, and you are unknowingly helping it do so every single day. Ford engineered these trucks to hit federal fuel economy targets, not to survive past your factory warranty. They left flaws in the software and the maintenance schedules that act like a slow-motion kill switch for your engine's most expensive components. If you own a 2.7 or 3.5 EcoBoost, you are likely driving a ticking financial time bomb. I see these trucks towed into my bay every single week. Scored bearings, massive shaft play, and compressor wheels ground into dust. The owners did not abuse their trucks. They simply trusted the dashboard gauges and left the factory defaults exactly as they came from the dealership. Today, we are exposing the exact settings and habits that are choking the oil supply to your turbos. We will break down exactly how to fix them before you get hit with a catastrophic repair bill. Setting 1. The auto start-stop. Death cycle, the absolute worst offender for premature turbo failure, is sitting right on your dashboard. It is the factory auto start-stop system. Ford programmed your engine to shut down the exact second your wheels stop moving. This saves a microscopic amount of fuel at red lights, but it inflicts severe thermal punishment on your turbocharger bearings. The mechanical reality: your EcoBoost turbochargers routinely spin at over 100,000 RPM under load. At those speeds, the center shaft relies entirely on a pressurized film of engine oil. This film keeps metal components from physically touching. That oil film is maintained by a mechanical oil pump. The pump spins only when the crankshaft is turning. Engine running, oil pump spins, high pressure oil, floating turbo shaft. Engine off, pump stops, zero oil pressure, coasting turbo shaft. When your engine abruptly shuts off at a red light, your oil pressure drops to 0 psi instantly. Yet, the physics of inertia mean that turbocharger shaft is still coasting. It is spinning at thousands of RPM with absolutely zero fresh oil pressure, feeding the bearing journal. The thermal trap-it gets worse when you factor in heat soak. You pull off a high-speed highway off-ramp and hit a red light at the bottom of the ramp. Your exhaust housing is glowing at nearly 900 Fahrenheit. The engine kills itself automatically. The oil stops moving. That static slug of oil trapped inside the turbo bearing housing instantly reaches its thermal limit. This causes a process called thermal coking. The oil literally cooks, turns into solid carbon varnish, and bakes onto the precision machined shaft. Baked oil, coking, restricts oil passages, acts like sandpaper, destroys bearings. The economic stakes leaving this system active saves you roughly 0.2 of a mile per gallon. Over an entire year of driving, that amounts to maybe $40 in fuel savings. Compare that to the cost of a turbo failure. Replacing a single turbocharger on a modern F-150 runs between $100 and $3,000. 10mm manifold studs frequently snap off inside the cylinder head during removal, driving labor costs through the roof. You are risking a $3,000 mechanical disaster to save $40 in gasoline. The immediate fix: you must disable this system every single time you start your truck. Locate the button on your center console featuring an A with a circular arrow around it. Make it a muscle memory habit to press it immediately after firing up the engine. If you hate pressing the button every drive, spend $100 on an inline aftermarket start-stop eliminator module. It installs behind the switch in 5 minutes, remembers your preference, and keeps the system permanently deactivated. Setting 2. The Eco Mode Towing Delusion. The second hidden killer is a driving configuration that many owners select, thinking they are helping the truck. It is using Eco Mode while hauling or towing heavy loads. Eco Mode aggressively remaps your transmission shift points and alters how the engine manages boost pressure. It forces the transmission to upshift as early as possible to keep engine RPM exceptionally low. The mechanical reality when you hook up a 7,000-pound trailer and leave the truck in Eco Mode: the transmission lugs the engine. It forces the powertrain to remain in 8th, 9th, or 10th gear while climbing a grade. To maintain highway speed in such a high gear, the engine cannot rely on RPM. It must rely entirely on massive boost pressure from the turbos. Your turbos are forced to cram up to 15 to 18 psi of boost into the intake manifold at just 1,800 engine RPM. This forces the turbochargers to work at peak capacity for miles at a time. It creates an environment of extreme sustained thermal stress. Eco mode plus heavy load, low engine RPM, max turbo boost, extreme exhaust gas temp, EGT. The clearance between your turboshaft and the bearing journal is measured in 10,000ths of an inch. When you subject that bearing to maximum exhaust gas temperatures without the high oil volume provided by higher engine RPM, you degrade the oil film. The economic stakes towing in eco mode might show a temporary fractional gain on your dashboard fuel economy screen, but it rapidly accelerates the degradation of your engine oil and your turbo bearings. You are actively trading the lifespan of a multi-$1,000 forced induction system for a statistical illusion on your fuel gauge. The immediate fix: never pull a trailer or carry significant payload in eco mode or normal mode. Switch your terrain management dial directly to TOW hot haul mode before you pull out of the driveway. TOW hot haul mode alters the shift logic to hold lower gears longer. This allows engine RPM to build naturally, which takes the sustained load off the turbos. Higher engine RPM spins the water pump and the oil pump faster. This increases the total volume of coolant and oil moving through the turbo housings, keeping peak operating temperatures safely controlled. Setting 3. The dashboard oil life trap. The single biggest maintenance myth Ford perpetuates is the digital oil life monitor on your dashboard. This software module routinely tells owners they can safely drive 10,000 miles between oil changes. If you follow that display, you are actively starving your turbocharger of the clean fluid it requires to survive. The mechanical reality: the EcoBoost is a gasoline direct injection (GDI) engine. All GDI engines suffer from an inherent engineering byproduct known as fuel dilution. During the combustion stroke, microscopic amounts of raw gasoline wash past the piston rings and enter the oil pan over thousands of miles. This raw fuel mixes directly with your engine oil. Fuel dilution lowers oil viscosity, lowers flash point, causes rapid oil film breakdown. A high-quality 5W30 motor oil quickly thins down to the equivalent of a 5W20 or worse. When that thinned, fuel-diluted oil enters a turbo center section spinning at 100,000 RPM and running at 800 Fahrenheit, it cannot maintain the required film strength. It shears, vaporizes, and fails to keep metal surfaces apart. The economic stakes: an extra oil change costs roughly $70 if you do it yourself, or $110 at a reputable shop. Leaving oil in an EcoBoost for 10,000 miles saves you roughly $200 over a 30,000-mile period. But that aged, sheared oil is actively depositing carbon inside your turbo feed lines. When those lines clog completely, the turbo starves instantly, seizes the shaft, and can send metal fragments straight into your engine's intake tract. Now you are no longer looking at a simple $2,000 turbo replacement. You are looking at a complete long block engine replacement costing upwards of $10,000. The immediate fix: completely ignore the digital oil life percentage on your dashboard display. Change your oil based strictly on mileage intervals. For any EcoBoost truck that encounters daily traffic, short commutes, towing, or extreme weather, change your oil every 3,000 to 5,000 miles maximum. Always use a premium, full synthetic oil that meets the current Ford WSS M2C961A1 specification. Never allow a quick lube shop to fill your truck with cheap, conventional bulk oil from a mystery drum. If you think these factory software settings and maintenance intervals are bad, you haven't seen the physical mechanical components Ford hid inside the engine plumbing that are quietly choking off fluid delivery right now. Setting 4. The extended idle warm-up illusion. Many F-150 owners routinely leave their trucks idling in the driveway for 15, 20, or even 30 minutes. They do this to warm up the cabin during freezing winters or cool it down using remote start in the scorching summer heat. This feels like a harmless luxury that protects your engine from cold wear. In reality, it creates a prolonged environment of low oil pressure and high thermal imbalance that quietly kills your turbocharger bearings. The mechanical reality: when your EcoBoost engine is idling, it produces very little exhaust gas volume. Because of this, the turbocharger turbine wheel is barely spinning, and the compressor is not building any boost. However, the exhaust gas that does pass through the engine is still hot enough to raise the temperature of the exhaust turbine housing. This creates a severe operational imbalance within the turbocharger's center housing rotating assembly. CHRA extended idling, low engine RPM, low oil pressure, 15 to 20 psi, plus minimal oil flow. Exhaust side traps engine heat, cooks stagnant oil inside low flow bearing. At a hot idle, your oil pump spins at its absolute minimum speed, generating low oil pressure, often dropping to around 15 to 20 psi. The total volume of oil flowing through the turbo's center bearing is heavily restricted compared to when you are driving down the road, because the oil is moving so slowly through the center section. It spends too much time absorbing heat from the exhaust side. The oil temperature inside the bearing spike, exceeding its thermal breakdown threshold. Compounding this issue is the nature of direct injection. At a prolonged idle, the fuel injection system runs slightly rich, and the combustion chamber temperatures are not high enough to completely vaporize the fuel. Unburnt gasoline washes past the cylinder walls, enters the oil pan, and aggressively dilutes the motor oil. You are left with a thin, fuel-soaked lubricant moving at a snail's pace through a hot turbo bearing. The economic stakes leaving your truck idling to get the cabin perfectly comfortable costs you pennies in wasted fuel. But the long-term cost is astronomical. Continuous extended idling accelerates bearing wear and shaft play. Once that shaft develops even a millimeter of play, the compressor wheel will make physical contact with the aluminum housing. When that happens, the turbocharger shrapnel is pulled directly into the engine's plastic intercooler and can easily pass into the intake valves. Turbo shaft play compressor wheel contacts, housing metal shrapnel, shuts down engine. Instead of a routine $2,000 turbo replacement, you are now paying a minimum of $4,500 to $6,000 to replace the turbo, pull and clean, or replace the entire charge air cooler system, and flush out metal debris from the intake tract before it destroys your combustion chambers. The immediate fix stop letting your EcoBoost idle for more than 2 to 3 minutes maximum, regardless of the outdoor temperature. Modern synthetic lubricants and computer-controlled fuel injection do not require a long warm-up period. The fastest and safest way to bring your engine, oil, and passenger cabin up to operating temperature is to drive the truck. Start the engine. Wait 30 to 60 seconds for the initial cold start high idle to drop and stabilize. Then put the truck in gear and drive away gently. Keep your throttle inputs light and avoid heavy acceleration until your coolant and oil temperature needles reach their normal operating ranges on the dashboard. This ensures your oil pump is spinning fast enough to provide maximum volume and pressure to the turbo bearings while they finish warming up. Setting 5. The hidden oil feed screen choke deep within the oiling plumbing of the EcoBoost engine lies a physical mechanical part that most owners do not even know exists. It is the turbocharger oil feed line filter screen. Ford placed a microscopic, fine mesh metal screen inside the oil feed system to catch any debris before it can enter the precision tolerances of the turbocharger bearings. While this sounds like a great protective measure on paper, it acts as a silent, invisible executioner for your turbos over time. The mechanical reality: every single drop of pressurized oil destined to lubricate and cool your turbocharger must pass through this tiny mesh screen. The clearances inside the mesh are incredibly tight. If you or a previous owner have ever followed Ford's factory 10,000-mile oil change intervals or used lower quality conventional oil blends, microscopic carbon deposits and varnish will form in the engine block. These free-floating carbon particles travel through the oil passages and get trapped by the turbo feed screen. Over 60,000 to 100,000 miles, these deposits slowly layer over the mesh, acting like a plaque-choked artery. Oil pump main engine gallery, high pressure, clogged screen turbo bearing, zero oil. The terrifying part of this design flaw is that your dashboard oil pressure gauge reads the pressure at the main engine gallery before the oil reaches the turbo feed line. Your dash will show a perfectly healthy, reassuring oil pressure reading. Meanwhile, the actual oil pressure exiting that clogged screen and entering your turbo bearing can drop down to almost nothing. The turbocharger is literally starved of oil, running metal on metal at 100,000 RPM, while the driver is completely blindsided because no warning lights are illuminated The economic stakes: the fine mesh oil screen itself is a simple $10 part. The labor to get to it varies by engine generation, but it is typically handled during routine upper engine services or line replacements. If you ignore this screen, it will completely plug up. The moment oil flow drops below the critical threshold, the turboshaft will instantly overheat, seize, or snap in half from thermal shock. A seized turbo means an immediate $2,500 repair bill for parts, gaskets, new oil lines, and labor. You are letting a cheap $10 piece of wire mesh dictate the survival of a multi-$1,000 forced induction system. The immediate fix if your F-150 has crossed the 80,000-mile mark, or if you purchased the truck used with an unverified or sketchy maintenance history, you need to address this screen immediately. When you take your truck in for service, or if you are a DIY mechanic, explicitly request to check, clean, or completely replace the turbocharger oil feed, line filters, and lines. Many veteran technicians recommend upgrading to updated, redesigned aftermarket oil feed lines that relocate or utilize larger, high-flow filtering elements that are far less prone to catastrophic clogging. Additionally, running a high-quality, full synthetic oil with high detergent properties will actively help dissolve and prevent the carbon varnish from accumulating on the mesh in the first place. Setting 6. The immediate shutdown. Heat bake. The final destructive habit is one that almost every truck owner commits out of simple convenience. It is pulling your truck straight into a parking space or driveway after a hard drive and instantly shutting down the ignition key, whether you were just cruising down the interstate at 75 mph for an hour, or pulling a heavy utility trailer up a steep grade. Cutting the engine immediately traps extreme thermal energy inside the heart of your powertrain, the mechanical reality when an EcoBoost engine is working hard. The exhaust gas temperatures, EGTs, entering the turbocharger's turbine housing routinely reach between 100 Fahrenheit and Fun 5. The heavy cast iron or steel turbo housing acts like a giant thermal sponge, soaking up massive amounts of this heat. While the engine is running, this extreme heat is kept in check because a continuous, heavy volume of engine oil and engine coolant is being pumped through the center bearing cartridge. The moment you turn the key off, the mechanical oil pump and the primary mechanical water pump stop spinning instantly. The flow of pressurized oil drops to zero. Instant shutdown. Fluid pumps stop. Full 500 Fahrenheit. Metal heat center section. Oil cooks into solid coke, with no oil moving to carry the heat away. The massive thermal energy stored in the exhaust housing radiates inward into the center bearing section. This is called heat soaking. The static stationary oil sitting inside the turbo bearing journal is instantly subjected to temperatures far exceeding its boiling and burning points. The oil literally boils, burns, and cooks into a rock-hard carbon crust known as coke. While Ford implemented a passive thermosiphon cooling feature on these turbos, where hot coolant naturally rises and pulls cooler water through the system after shutdown, it is simply not enough to stop the oil from coking if you shut the truck down completely hot. Over time, these hard carbon crusts build up on the bearing surfaces, acting like a coarse sandpaper that grinds away at the turbo shaft every time you start the engine. The economic stakes: taking the time to let your truck cool down costs you absolutely nothing but 90 seconds of your day. Failing to do so guarantees a slow, grinding death for your turbocharger bearings. Once coking destroys the internal seals, the turbo will begin pulling engine oil straight into the exhaust pipe, resulting in thick blue smoke and a failed emissions system. Or it will leak oil into the intake, destroying your spark plugs and causing severe engine misfires. Fixing a coked, smoking turbo system means spending $2,000 to $3,500 on new turbo assemblies and hardware, all because you couldn't wait a minute and a half before turning off the key. The immediate fix: establish a strict cool-down protocol based on how you just drove the truck. If you have just completed a long highway cruise, finished pulling a trailer, or were driving aggressively up a steep incline, do not shut the engine off right away. Park the vehicle, place the transmission in park, and let the engine idle for 60 to 90 seconds before turning the key off. During this 90-second idle window, the engine is producing very little heat, but the oil pump and water pump are still spinning at full operational capacity. This allows a massive volume of fresh, cool oil and water to cycle through the turbochargers, safely pulling the peak thermal energy out of the iron housings and carrying it away by the time you turn the engine off. The temperatures inside the bearing housing will have dropped well below the oil's coking threshold, keeping your passages clean and your bearings perfectly protected. If you think managing your idle times and replacing hidden filters is enough to completely bulletproof your EcoBoost, you are missing the single most deceptive trap Ford built into the dashboard configuration. One that tricks you into believing your engine is completely healthy right up until the exact second it self-destructs. Setting 7. The low viscosity fuel saver oil trap, the penultimate trap, destroying your F-150's forced induction system, is a specification change hidden right on your oil filler cap. Ford, like many modern manufacturers, push the boundaries of engine oil specifications to squeeze out a microscopic fraction of a percent in corporate average fuel economy, CAFE numbers. They did this by shifting their primary oil recommendation to thinner, ultra-low viscosity weights like 5W20 or even 0W30 formulation limits under specific operating templates. They tell you it is perfectly engineered for your EcoBoost, but under real-world truck conditions, it is a recipe for catastrophic bearing wear. The mechanical reality, the center cartridge of an EcoBoost turbocharger operates under extreme mechanical dynamics. The internal shaft does not ride on traditional roller bearings. It floats on a dynamic hydrodynamic fluid film. This means the shaft is separated from the brass or steel bearing sleeve solely by the physical thickness of the oil moving through the assembly under pressure. This thickness is known as the high-temperature, high-shear (HTHS) dynamic viscosity. Low-viscosity oil, thin fluid film, high-heat shear, boundary lubrication, metal contacts metal. When you operate a heavily loaded truck on a hot summer afternoon, the oil temperatures inside the turbocharger cartridge easily exceed 240 Fahrenheit. At these extreme thermal thresholds, a standard thin oil blend loses its structural integrity. The molecular chains shear apart, that protective fluid film thins out until it is no thicker than water. When the film collapses, your turbo enters what engineers call boundary lubrication, a polite term for metal-on-metal friction at 100,000 RPM, normal load. Thicker, full synthetic film, zero shaft wear. Severe load, thin factory spec, blend shears, shaft scores, bearing sleeve. The clearance between that spinning shaft and its housing sleeve is microscopic. If the oil cannot maintain its physical presence under shear force, the shaft will micro-weld itself to the bearing sleeve for a fraction of a millisecond. This tears microscopic grooves into the steel, creating immediate shaft play that steadily degrades your boost efficiency and creates an unfixable mechanical imbalance. The economic stakes opting for the absolute thinnest oil, recommended under the guise of optimizing fuel economy, might save you a completely imperceptible $15 in fuel over a 5,000-mile period. However, the mechanical cost of running sheared, ultra-thin fluid through a hot turbo is devastating. Once the shaft scores the bearing sleeve, oil seals fail completely. Pressurized oil begins spraying directly into the hot exhaust stream or leaking into the intake plumbing. This triggers a sudden P0299 underboost diagnostic trouble code, immediately throwing your F-150 into a limp mode state on the highway, replacing the damaged turbocharger assemblies, flushing the contaminated oil galleries, and cleaning out the oil-soaked catalytic converters will quickly land you an invoice totaling upward of $3,500 at an independent shop, and closer to $5,000 at a franchise dealership. The immediate fix stop, blindly following the fuel economy-biased oil weight recommendations if you use your truck like a real truck. If you regularly tow, haul, or live in a region that sees high ambient summer temperatures, step up your protection. Always select a premium, true 100% full synthetic oil that explicitly carries a robust HTHS rating and meets or exceeds stringent European or severe duty industry standards. Ensure the oil has a higher thermal breakdown threshold than cheap dealer bulk blends for severe duty or high mileage EcoBoost platforms. Moving away from thin synthetic blends and strictly utilizing a high-tier full synthetic 5W30 ensures that even when your turbo is glowing under load, the fluid film will maintain its structural thickness, preventing metal-to-metal contact completely. Setting 8. The simulated dummy dashboard oil gauge. We have reached the absolute most deceptive, dangerous, and outright manipulative feature Ford designed into your F-150's instrument cluster. It is the factory dashboard oil pressure gauge. Every single time you climb into your truck, you look at that needle resting comfortably right in the middle of the bracket, or you see a clean digital graphic indicating that your oil pressure is completely normal. It gives you a profound, absolute sense of mechanical security, but it is a complete lie. The gauge on your dashboard is not a gauge at all. It is a programmed illusion. The mechanical reality on almost every modern Ford F-150, the dashboard oil pressure gauge, does not respond to an actual variable pressure sending unit. Instead, the engine block is equipped with a basic binary electrical pressure switch. This switch is calibrated to a laughably low mechanical threshold, typically around 5 to 7 psi, actual pressure 6 psi. Switch closes software, sends dashboard needle to normal center position actual pressure, 6 psi, switch opens software. Drops needle to 0 plus triggers, red oil light. The vehicle's computer reads this simple on-off switch. If your engine is producing anything greater than a measly 6 psi of oil pressure, the computer instructs the dashboard cluster to move the needle directly to the middle, normal position, and hold it perfectly still. Whether your actual engine oil pressure is a healthy 45 psi or a critically low 8 psi, the needle on your dashboard will sit in the exact same reassuring spot. It is a simulated display designed entirely to prevent customers from visiting dealerships to complain about normal, minor fluctuations in fluid pressure. Real engine state. Dashboard display. Oil pressure. 40 psi, healthy DNA needle in center, normal. Oil pressure, 8 psi. Starving turbo, needle in center, normal. Oil pressure, 5 psi destroyed and needle drops to 0, too late. This is an unmitigated disaster for a highly sophisticated twin turbocharged engine. Your engine oil could be heavily diluted with raw fuel, running dangerously hot, and dropping to a pressure level that is completely insufficient to feed the restrictive lines of your turbochargers. The turbocharger could be actively grinding its bearings to pieces, starving for fluid volume, while you cruise down the highway looking at a dashboard that confidently tells you everything is flawless. By the time that binary switch finally drops below 6 psi and illuminates the red oil warning light on your dash, your engine bearings are already ruined, your turbo shafts are snapped, and your entire powertrain is completely unrecoverable. The economic stakes trusting that Deceptive dashboard gauge is the single most expensive mistake you can make. Because there is no real-time warning, owners continue to drive their trucks through the early stages of oil starvation, transforming a minor maintenance oversight into a total mechanical catastrophe. When a turbocharger bearing completely disintegrates due to undetected low pressure, it drops hot metal shards directly into the engine's main oil pan. The oil pump picks up those fragments and pumps them straight through the engine's main bearings, the cam phasers, and the variable valve timing solenoids. You are no longer dealing with a simple component replacement. You are looking at a total, catastrophic engine failure. The financial stake is a minimum $10,000 to $12,000 bill for a completely new crate engine, all because Ford chose to show you a comforting digital illusion instead of the raw, honest mechanical truth. The immediate fix: you must completely stop driving by the factory gauges and start driving by a strict, proactive maintenance schedule. If you want to know what is actually happening inside your engine, bypass Ford's deceptive display entirely. Purchase an electronic OBD2 diagnostic scan tool or a digital gauge monitor that plugs directly into your truck's diagnostic port under the steering column. Utilizing advanced aftermarket software, you can configure a secondary screen to read the raw, unedited data streams from the internal engine sensors, or you can install a physical, mechanical oil pressure sending unit directly into the engine block gallery. This gives you a true, real-time readout of your operating pressures. If you see your hot idle pressure trending down towards dangerous territory, You can shut the vehicle down and diagnose the issue before a component fails. The ultimate EcoBoost survival blueprint to protect your investment and keep your Ford F-150 out of my repair bay. You must actively reject the factory defaults and implement this 5-step survival blueprint immediately. Kill the auto start-stop. Make it an absolute habit to press the deactivation button every single time you start the truck. Or install a physical hardware eliminator module to kill it permanently. Dump the long intervals. Throw Ford's 10,000-mile oil life monitor out the window. Change your engine oil every 3,000 to 5,000 miles maximum using a premium, heavy-duty full synthetic 5W230 fluid Dext a post-run idle. Never shut your engine off immediately after high-speed highway driving or towing. Give the truck 60 to 90 seconds of stationary idle time to pump fresh oil through the hot turbo housings and prevent destructive coking. Match your drive modes. Stop towing heavy loads in eco mode. Switch the terrain dial directly to tow haul mode to keep engine RPM elevated, maximizing oil and coolant flow when the turbos are working their hardest. Maintain the hidden filters if your truck has crossed 80,000 miles. Proactively service or replace the hidden turbocharger oil feed line filter screens and lines before they plug solid with carbon varnish. Your truck is an incredibly capable machine, but it is bound by the laws of mechanical engineering. Laws that manufacturer marketing departments and emissions lawyers routinely ignore. Stop letting factory software settings strangle your oil supply. Go out to your truck this week. Take control of your maintenance. And protect your investment before the factory defaults. Force you into a multi-$1,000 rebuild.